Good morning guys, welcome to videos on our diet tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do press subscribe button and notification bell and also our update on this YouTube channel. Today I'm going to be considering 2022 Neco chemistry practical, specifically under the volumetric analysis. And this year we are given an acid-based titration. The acid is what? Is nitrified acid, and the base is what? Is sodium triiodocarbonate 4. It's a titration between a strong acid and a strong and a weak base. The titration is going to work between weak, strong acid versus weak base. So, and this kind of titration involves the use of ethyl orange, as you can see here. So, the titration between a strong acid, nitrified acid, and a weak base, which is sodium triiodocarbonate 4. And this is a likely question for this year. A is a solution of triiodonitrified acid, and B is a solution containing 1.05 gram of anhydrous sodium triiodocarbonate 4 in 250 centiliter cube of solution. Now, A puts A into the buret and titrate it against 20 centiliter cube or 25 centiliter cube portion of B using methyl orange as indicator. Repeat the exercise to obtain consistent titrate. Tabulate your reading and calculate the average volume of A used. Now we have to put A into the buret. I'll rinse every of my apparatus with the reagent I'm going to use. Like for instance, now I'm going to fill in A inside the buret. I'm rinsing it with A now. So ensure that you rinse your apparatus with the reagent given to you before you even start your titration. So putting A inside buret now. Putting A inside buret. Putting A inside buret. So now you can reduce this now to the meniscus. So this is on the meniscus. So now we have our Our A being filled inside buret, and now the next thing is to titrate this A down with the portion of B using the methyl orange. Now we are going to pipette B with, now I'm using 25 centiliter cube of pipette now, 25 centiliter cube of pipette, so I'm going to pipette B with this now. So this is 25 centiliter cube of B, 25 centiliter cube of B, as you can see now. So 25 centiliter cube of B. This B has been rinsed with With B itself. So you must ensure that you rinse your conical flask with the solution you wanted to use it with. So that's why this one is coming up. Now let's get so now here we have our B. Then we have to add 2 drops of the indicator. 2 drops of the indicator. So you can see the change in color, which is light yellow. Now that's the color of indicator in base, which is sodium triazocarbonate 4. So now let's run this now from 7 moles now, and shake while you are running this. Colors are about to change. So we have the color change at 14.50. So we can have what you see. This is light orange. So that's our end point. Now let's plot our table. The first thing to record here is the volume of the pipette used. The volume of pipette used is 25 centimeter cube. Volume of pipette used is 25 centimeter cube. Then the first column here is the what? Buret reading column. Buret reading column, which is in centimeter cube. In centimeter cube. Then the first one is rough. The first one is rough. The first one is rough. The second one here is first. And the third one is second title. That's the first title, the second title. So now, with this now, the first row here will be what? The final buret reading. Final buret reading. Final buret reading. The initial what? Buret reading. The initial buret reading. Initial buret reading. And the volume of A used. The volume of A used. Volume of A used is centimeter cube. So now for our factor, the initial value here was 0.00. Now initial is 0.00, and the final one is what? The final buret reading here is what? 14.50. So meaning that we have 14.50 here as our first value. This is our rough title. You can see the color change from light yellow to light orange, which is the end point. So let's put this one away and carry out the first title value. Now, always ensure that you rinse your conical flask with the reagent that you want to use it with. So that's the first step. Then the next thing is to what? Repeat the same procedure to have consistent or to obtain consistent values. So now I'm pipetting my base again. So release it a little bit. So this is 25 centimeter cube of what? Of the base. Add 2 drops of the what? Methyl orange. 2 drops. We have 1, then 2. So we have a light yellow. So now, with this now, Don't forget that our initial now what? 14.50. Initial now is 14.50. Then run your A from the buret. Getting close to 29. Okay. You can see we are getting to almost the end point. So this is 20, case 29, 29.0, 29.0. So now with that now, let's run the third analysis. So we follow the same procedure, which is to pipette again. So this is to add 2 drops of the indicator. So you have light yellow here, then. So from 29, initially we have about 29 now, 29.00. Now let's run this one now. So this. Almost there. So I have light orange here. So here we have 40. Here we have 44, 43 point what? For 3.60. For 3.60. Now let's for 3.60. Now let's take our calculator and do some calculation. Now I minus this one from this. So this one gives us 0, 5. Now after about this is 28. Now this one remains 4. So we have 14.50 here. What about this? We have 0, 6. This is point. Now, when you borrow 1 from this one, so it's 13 minus 9. 13 minus 9 will give you what? 4. Then we have 3 here, which is what? 14.60. You can see that what? These values are concordant. First title and second title. 14.50, then 14.60. It's our what? It's our first title and second title value. So with this now, let's go into what? To the calculation that we have here. So having gotten our table of value now, the first thing now is to calculate your what? The average volume of A used. Average volume of A used, which is your RC, equal to the first title now plus the second title value divided by what? 2. So what do we have? We have 14.50 plus 14.60. So 14.50 plus 14.60 divided by 2, we have what? 14.55 centimeter what? Cube. So that is the volume of what? Of A used, the average volume of what? A used. Now, having gotten the average volume of A used now, the equation for the action is given as follows, which is 2HNO3 plus Na2CO3 to give 2NaNO3 plus CO2 plus H2O. From the results now and information provided, calculate the concentration of B in mole per dm cube. The concentration of B in mole per dm cube. And in order to calculate the concentration of B in mole per dm cube now, which is B over 1, the concentration of B in mole per dm cube. Now, we are talking about concentration in mole per dm cube. We are talking about what? Molar concentration. We are talking about molar concentration of B. Molar conc of B. So, concentration in mole per dm cube is saying as what? Molar conc of B, which can be obtained in 2 ways. The first way is what? By using molar concentration is equal to what? Mass concentration all over what? Molar mass. That is molar conc of B now is equal to mass conc of B all over its molar mass. So now which is the what method I'm going to use here? The first thing now is to get the what? The mass conc of what? B. The mass concentration of B can be obtained as what? Mass all over what? Volume. That is the mass of B. And we are told that B is a solution containing 1.05 gram of anhydrous sodium trihydrocarbonate 4. So the mass of sodium trihydrocarbonate 4, which is N2CO3, all over the volume of the solution itself. Volume of the solution. So that's how we are going to get the what? Mass concentration of B. So now the mass of N2CO3 from the question is 1.05 gram all over. Then the volume of solution is 250 centimeter cube. 250 centimeter cube to dm cube. The first thing we are going to do is that volume in dm cube. Volume in dm cube. The volume of solution now in dm cube will be 250 divided by 1000, which is 0.25 dm cube. So breaking 0.25 dm cube now to this formula now, 0.25 dm cube. So your mass conc will now be what now? 1.05 divided by 0.25. So we have 4.2 gram per dm cube. So that's that about mass concentration of B in gram per dm cube. This is concentration of what? B in gram per dm cube. Don't forget we are looking for concentration of B in mole per dm cube. Now the next thing is to now get the molar mass of B. What is the molar mass of B? Molar mass of B is same as what? Molar mass of sodium trihydrocarbonate 4, which is Na2CO3, which is 2 into bracket 23 plus 12 plus 3 bracket 16. So we have 46 plus 2 times 23. Don't forget 23 is the atomic mass of sodium, which is what? Which is 23. The atomic mass of carbon is what? Is 12. The atomic mass of oxygen is 16. And oxygen is 3 here. The molecules of what? The number of moles of oxygen here is 3. So 3 times 16. Sodium is what? 2 times 23 plus 12 plus 3 times 16. That would be 46 plus 12 plus 48. So adding this one up, will give you what? 106. Okay, let's check. So this is 106 gram per mole. Always remember your unit, gram per mole. So this is what? Molar mass of Na2CO3. Now, with this now, we can now calculate the concentration of B in mole per dm3, which is same thing as what? Molar count. So the concentration of B in mole per dm3, which is molar count, will now be equal to what? Molar count of B will now be equal to the mass concentration which you have obtained as what? 44.2 gram per dm3 all over 106, which is the molar mass. So 4.2 divided by 106. We are going to have what? We are having what? 0.0396 mole per dm cube. Now 0.0396 mole per dm cube. We approximate this one to 3 decimal place now. They are going to have 0.0. Now 6 to 9 now it gives you what? 10. 10 to 3 it gives you 0.40 mole per dm cube. So that's that about the first question. So now that's the first question for the calculation. Now the second question here says that the concentration of A in mole per dm cube. The concentration of A in mole per dm cube. I'll have to clean this side. The concentration of A concentration of A in mole per dm cube. Concentration of A in mole per dm cube. Concentration of A in mole per dm cube. That is Ca. That's Ca. Now, how you go about this? You have to look for the concentration of what? Of A in mole per dm cube. Now, using the general formula which is known as CAVA all over CBVB equal to NA over what? NB. Now, to calculate the what? The concentration of A, we are going to use this formula because we have no information about A except the volume of what? Of A used. So that's why we are using this formula now. So we are having CA to be unknown, VA to be 14.55 centimeter cube. Then the next thing, CB is 0.0396 centimeter cube. I don't use the approximate value, but I use what? 0.0396 centimeter cube. Then we have what? We have the VB to the volume of the pipette, which is the volume of the pipette, which is 25 centimeter cube. And NA is obtained from the what? From the reaction itself. Now look at this. The reaction is what? HN3 plus what? Sodium triisocarbonate 4, which is the B. Now the number of mole of acid here, which is Na, is 2. And number of mole of what? Base, which is as sodium triisocarbonate 4 is 1. So Lb is 1. So using this formula now, substituting your what? Your values, what do we have? We have Ca multiplied by 14.55 all over Cb. What's your Cb? Your Cb is 0.0396 multiplied by your Vb. Your Vb is 25 equal to your Na is 2 all over what? 1. So by cross multiplication now, we have CA times 14.55 equal to 2 times 0.0396 times 25. Now divide both sides by 14.55. 14.55. So what's our CA? Our CA now what? Our CA, compress this one as once by bracketing it. Just put everything in bracket so that you make your calculation more easier. So for bracket 2 times 0.0396 multiplied by 25. Multiply by 25, multiply bracket close now, divided by 14.55. So CA is 0.136 mole per dm cube. Mole per dm cube to 3 decimal place. So now that is our concentration of A in mole per dm cube. A mole per dm cube. Now, having done this now, all the next thing to do, we have to calculate the concentration of A in gram per dm cube. Concentration of A in gram per dm cube. Now, please follow the sequence here so that you don't miss anything. So, we have what? I'm playing this one now. So the concentration of A in gram per dm cube. Concentration of A in gram per dm cube. This is talking about the mass concentration of A. Now, the mass concentration of A. Now, to calculate the mass concentration of A, now we use the formula mass conc of A is equal to molar concentration of A multiplied by what? The molar mass of A. Now we have gotten our molar conc of A, which is 0.136 mole per dm cube. But we have to obtain the molar mass first. The molar mass of A. So the molar mass of A, which is HNO3, the same thing as what? First H here is given as 1. Nitrogen is 14. Atomic mass of nitrogen is 14. The atomic mass of oxygen is 16, 3 bracket 16. So it means 1 plus 14 plus 48. 14 plus 48 plus 1. That is 63 gram per mole. The unit of molar mass is what? Gram per mole. Now, having gotten the word molar mass, now the mass concentration, now which is concentration in gram per dm cube. Mass concentration, which is simply as concentration of A in gram per dm cube, will now be equal to the molar conc of A, which is 0.136 times the 63 that you just obtained now. So 63 multiplied by 0.136. We have what? 8.568. 8.568 gram per dm cube. So that's the unit. Now, related to what? To this simple, this is 1, 2, 3. We have 8.57 gram per dm cube. So that's that about that. Last question here, which is mark 4, is the volume of gas evolved in the reaction at XTP. The volume of gas evolved in doing the reaction at STP. Now when we go back to the what? The equation of the reaction, we have HNO3 plus N2CO3 to give us what? NaNO3 plus CO2 plus H2O. Now, this is the equation of the reaction. You can see that what? 2 moles. You have to ensure that you have balanced equation which has been given to you from the question or which will be given to you in the question. Now, the first thing is to ensure that, okay, the equation is balanced. Now, you can see that 2 moles of acid reacts to 1 mole of what? 1 mole of sodium carbonate to give what? 1 mole of what? Gas. The gas that we have there is CO2. The other gas we have there is CO2. So meaning that 1 mole of this, 1 mole of the base produce 1 mole of what? CO2. So with that now, it now asks us to find the volume of the what? The gas evolved at STP. Meaning that since 1 mole of this produce 1 mole of this, it means that 24 what? 24 1 mole of CO2 evolved is equal to 1 multiplied by 22.4 dmq, which is what? The volume occupied by the gas at STP, which is 22.4 dmq. So that's that about that, and these are the likely questions. This is likely questions that Neco might set based on what you are given this year. And mind you, it might not be what 250 centimeter cube, it might be what 1000 centimeter cube initially. But whichever the case, the questions will always come in this format. So if you haven't subscribed, please do press subscribe button and notification bell, and that's all our updates on this YouTube channel. See you in the subsequent class.